Algebra 1, lesson 97. We are graphing linear inequalities. So these are no longer on just a number line. We are going to be on a coordinate plane. So graphing inequalities is similar to graphing linear equations. However, instead of just being on one line, we shade an area where the solutions can have. So we have many, many different solutions. Not just a line of them, we have a whole side of the graph that is possible. So before we graph, let's figure out if some ordered pairs are solutions to these inequalities. So remember, we have two different variables now. We have x and we have y. So we're going to plug those in to decide, is the statement true? So we plug in y is 4 and say that, is that greater than 5 times 0 minus 1? So we say that's 4 is greater than negative 1. Is that true? Yes, it is. So when we graph these, we would actually want to include that solution with our shading. And the next one, 3 comma negative 3. We would plug in y as negative 3 and have less than negative 3 times 3 plus 6. So that means negative 3 is less than negative 3. Is that a true statement? No. Ends up being that this is on our line, but because we have a less than symbol rather than a less than or equal to symbol, it would not be included in the solutions. Let's try a couple more here. So negative 4 comma 8, well, in this case we just have one variable, so we use that 8 as y. 8 is less than or equal to 9? Yes, that is true. Okay, on a coordinate plane we would actually be able to graph this as a horizontal line with our shading as well. And on the right side here, 3 comma negative 2, saying y is negative 2 is less than or equal to 2 times 3 minus 8. That means we have negative 2 is less than or equal to 6 minus 8, which is negative 2. Is negative 2 less than or equal to negative 2? Yes, it is. So we're good to go there. We would want to include that solution. 2 comma negative 2 here, we would have negative 2 is greater than 2 minus 3, or negative 2 is greater than negative 1. That is not true. So in our shading, we would not want to include that solution. And negative 2 comma 8, we would say, well, x is negative 2 is greater than negative 4. That is a true statement. We could graph this on a number line or on a coordinate plane as a vertical line. Now, graphing the equation of an inequality is similar to graphing an equation for just a regular line. Okay, so the first thing, we just need to graph the equation. Now it says with the correct type of line. So in this, what this means is that if it has a less than symbol or a greater than symbol, just like if we were on a number line, something like if we had x is greater than 2, we would say, oh, that's an open dot going to the right from 2. Well, similarly, with a less than sign on a graph, we would put a dotted line. So we would put our normal equation, so y-intercept of 2, a slope of 1. But in this case, we would actually put a dotted, a dashed line through the points, showing that this is open, showing that it's not actually solution on the line because we need to be less than that. And then we test a point. The easiest point to test is actually 0, 0. Now, if your line goes through 0, 0, you're going to have to pick a different point. But we test the point into our inequality, just like we tested on the other page, to say 0 is less than 0 plus 2, so 0 is less than 2. That is a true statement, which means 0, 0 right here is a solution to this inequality. So we would need to shade, just like we would an arrow, we would shade all of these possible solutions on our inequality. Okay, so we would shade in if the point was true. If it wasn't true, we would shade away. So let's try again. So we're going to graph this inequality, decide on a certain type of line, check a point, and shade. So let's graph the line, and we do need a dotted line since this is a greater than symbol rather than a greater than or equal to symbol. So we start with a y-intercept of negative 3 and then a negative 3/4 slope. So we're going to go down 3 over 4, down 3 over 4. Or we could go up 3 over left 4, up 3, left 4. And once again, this is a dashed line since it's a greater than symbol. But of course, remember, always put your arrows showing that it goes to infinity. And then we test a point. Let's say we test our point 0, 0. So 0 is greater than negative 3/4 times 0 minus 3. So 0 is greater than negative 3. That is a true statement, so we want to include our point 0, 0. So we shade above the line this time because we want to include 0, 0, meaning that anything in the shaded region is a solution to this inequality. Let's just try a couple more here. So in this, we have the equation y is less than or equal to 1/2 x plus 2. So we plot 2, go up 1 over 2 for our slope, or down 1 left 2. And since this is a less than or equal to sign, we would have a solid line through the points. Solid line because we can be equal to it. And then we test a point. We say 0 is less than or equal to 1/2 times 0 plus 2. So is 0 less than or equal to 2? Yes, it is. So we include 0, 0. Remember, if we were to plug something in like that and it comes up with an untrue statement, we would shade away from that point because we can't have it as a solution. All right, just a couple more here. Y is greater than 3. Y is greater than 3. Now, when you would normally look at this, you would probably say, you know what, this would go on a numbered line as 3, open dot, going to the right. But since we're on a coordinate plane, if I were to graph the equation y equals 3, that would be a horizontal line where y equals 3. Okay, that would be our equation line. Now, since this is an inequality and it's just a greater than sign, we would need a dashed line. So I'm going to change this just to a dashed line really quick. Remember, y equals situations, or y situations are horizontal line, x situations are a vertical line. So we have my graph. Now I need to shade, so I test a point. I say, is 0 greater than 3? No, it's not. So I don't want to include 0, 0, so I would actually end up shading above the line. So shading above the line because I can't include 0, 0. It doesn't satisfy the inequality. All right. And x is less than 4. X is less than 4. So in this case, this is a vertical line where x is 4. So, and once again, it's not a solid line, it's a dashed line. And once again, we're going to test 0, 0. So we say 0, is it less than 4? Yes, it is. So I would actually include this entire side of the graph, because 0, 0 does satisfy this equation. All right. So we can also use calculators to do this. That's in lab number 9. So you can use a graphing calculator, but always remember we have to get y by itself in order to graph things. And it's helpful for when we graph things by hand. So in this case, we would have to subtract 16x from each side and get 4y is less than or equal to negative 16x plus 8. And then we would divide by 4 to get y is less than or equal to negative 4x plus 2. So we would check that or plot it at a y-intercept of 2, a slope of negative 4, and check 0, 0 to say 0 is less than or equal to negative 4 times 0 plus 2. So is 0 less than or equal to 2? Yes, it is. So we would include 0, 0 in our shading. All right, so these are the instructions for lab number 9. You can try them out by yourself, lab practice here. And you can try some of these on your own here. Remember, you got to get y by itself in order to do this. And just to remind us all, if we have y and we have to subtract 3x here, and we have negative y is less than negative 3x minus 4, and we have to divide by a negative 1. Remember, even in these, the inequality signs flip. So we have a greater than 3x plus 4. So remember that all of those rules still apply even when we're graphing on a coordinate plane. All right, so write the linear inequality. Here we have a horizontal line, so we would normally say y is equal to 1 or negative 1, but in this case we are saying y is less than negative 1. Because if we were to plug in 0, 0, we would say, is 0 less than negative 1? No, it's not, and that's why we don't have it included. The other way to think about it is that y, where it's shaded, is lower than -1, so it's less than -1. All right, and this one here, our normal equation would be, well, we have this point right here, and it looks like it's at -4 based on the labels here. So we would have a y-intercept of -4 and a slope of 1, okay, +1. So we would say y is normally equal to 1x minus 4. But in this case, it's an inequality, so we would say, is 0, 0 part of that solution? So let's try it. Is it y is greater than x minus 4? Well, if we plug in 0, 0, we would have 0 is greater than -4, which is a true statement. So we have y is greater than 1x minus 4. So once again, if it's above, typically you can think about it as greater than, and so, but you always are checking your work. All right, well, here are just a couple other problems that you can try here if you would like. And similarly, word problems here. Carla will attend a school carnival and she plans to spend no more than $12. Each game costs 2 and food item costs 3. So write and graph an inequality to show the total cost at the carnival. All right, so think about creating an equation from that. Okay, and how much she can spend. Think about she can't spend more than $12, so it has to be less than or equal to $12. And we could say each game is 2x and each food item is 3y. So we could graph that. All right, well, I hope this is helpful for your homework and for studying.